My name's Bob, and I'm a passionate developer in the San Francisco Bay Area. My goal is to show new developers how accessible programming can actually be. This video will explain the difference between imperative and declarative code. There's a common lesson that computer science teachers use to demonstrate how useless computers are without proper human instruction. Imagine the teacher, Miss Lovelace, is at the front of the classroom with a table. On this table, you see a loaf of bread, a jar of peanut butter, a jar of jelly, and a knife. The goal is to make a PB&J sandwich. Miss Lovelace tells the class that she's going to act as the computer. She calls on a student to the left of you. Let's call him Dennis Ritchie. She asks him for instructions to create the sandwich. Dennis says, "Put the peanut butter and jelly on the bread and squeeze the bread together." Miss Lovelace proceeds to set the jars on top of the loaf of bread and squeeze the loaf of bread from the sides, which causes the jars to fall off and the bread to be crushed. Next, she asks another student, Linus Torvalds, to do the same thing. Linus says, "Open the bag that contains the bread. Open the jars, scoop out the peanut butter onto one piece of bread, scoop out the jelly onto another piece of bread, and push the two pieces together." Miss Lovelace violently rips the loaf of bread open from the middle, ripping the bread in the process. She scoops out the peanut butter and jelly respectively onto the ripped slices with her bare hands and smashes everything together with the tasty condiments on the outside. Finally, it's your turn. Since you're smarter than Dennis and Linus, you say, grab the loaf of bread with your left hand and position it so that the end with the twist tie is facing you. Untwist the twist tie on the bread bag counterclockwise until it falls off. Reach into the bag with your right hand and gently remove 3 slices. Set the end slice off to the side of the table to discard later. Set the other 2 slices on the table side by side with the soft side of the bread facing upwards. Gently unscrew the lid of the peanut butter counterclockwise until it's loose enough to remove. Set the lid near the discarded piece of bread. Pick up the knife with your right hand while holding the peanut butter jar in place with your left hand. Scoop exactly 2 tablespoons of peanut butter out of the peanut butter jar using the knife that's in your right hand. Move your left hand from the peanut butter jar onto the piece of bread to stabilize it. Gently rub the peanut butter off of the knife and onto the top portion of the upward facing slice of bread on the left side while the knife is parallel to the bread. I'm sure you know how the rest of the story goes. Congratulations, you're smarter than Dennis Ritchie and Linus Torvalds, and you win a delicious PB&J sandwich. This is imperative programming. You tell the computer exactly how to execute each step while making absolutely no assumptions that the computer will understand what you're saying. This is how the browser API works. Instead of a table, you have a blank document with an API that's referred to as the DOM or Document Object Model. Instead of a teacher, you have a JavaScript interpreter and an HTML rendering engine. Instead of bread, peanut butter, and a knife, you have HTML DOM elements such as div, span, and unordered lists. There are a whole host of other primitives which are building blocks that are used to create user interfaces. Let's take a look at how this works in practice by building a simple app that tells you if a number you entered is even or odd. Let's start by creating an HTML document. It's going to be called index.html. First, let's give ourselves some boilerplate. And now we can give it a title. Next, we're going to create a place to mount our app. We do that by creating a div and giving it an ID of app. We're going to create some code to populate the DOM with elements and functionality. We're going to give ourselves a script tag here so we can write some JavaScript within the HTML document. So we're going to create an app object which represents the container of our app. We're going to mount the container into the body of the DOM or Document Object Model. Then we're going to create an input element. Next, we're going to create an ID for the input to reference later. Then we're going to create a button element. After that, we're going to give the button some text so we know what the button does. Then we're going to create a function. That function is going to be called when the button is clicked. We're going to give the button an event listener so it can react to those clicks. We're going to set the event to check number, the name of the function, and we're going to set it to the pointer of that function. After that, we're going to insert the input and the button into our app. Now, let's start the process. What we're doing here is we're creating a variable called app, and we're referencing this div right here with the ID of app. After that, we can mount this into our document. Next, we create the input element. We're going to give our input some values. We have an ID and a type. Then we create the button. Again, we do this with document.createElement and we call button. Now we need to give the button some text, and the text is going to say check. Here we're creating that function so that we have some reactivity. This function is going to find the input element with a new value by querying by the input ID. It's going to get the current value, and it's going to make sure that it's an integer. It's going to make sure the number exists and that it's valid. Here, we're creating a variable called input element using document.querySelector, and we're calling the input ID that we created right here. Next, we get the current value by calling this input element variable that we just created, and we're checking the value. We're parsing it as an integer. We need to make sure that it's valid and that it exists. The number is going to be a value and it's going to exist. If this is not the case, then we're going to create an alert if there's no number. We'll just say no number provided. If everything is valid, we have an else statement. If the number exists, we're going to check if it's even or odd. Then we're going to create an alert to display whether the number is even or odd. We do this by creating a variable called isEven. We're using the modulus operator to check the current value if the current value mod 2 is 0. Next, we're going to create an alert, and we're using a ternary operator here. Now, we're going to give the button the event listener. We do this by calling the button and adding an event listener onto it. It's a click event listener, and then we're calling this check number function by referencing the pointer value. Mount the input and the button into the DOM. So let's take a look at how this works. Here, it's a number. Here, we set the type to number. So we can't enter any letters here. If we enter the number 5 and we hit check, it says the number is odd. If we change this to 4 and hit check, it'll say that the number is even. This is an awful lot of code to do something very, very simple. Now, let's get rid of all the comments and see what it looks like without that. There's a lot that you need to parse through to figure out what's actually happening here. It's going to be more difficult to debug, and when you're building more complicated applications, you run into a larger problem. That larger problem is that you need to re-render the DOM every time you make a significant change to it. Now let's see what this looks like with a declarative style of code. The next day in class, Miss Lovelace tells you that she learned a new PB&J framework called PB.js. This framework has shortcuts for common steps in the sandwich making process. She now knows what you mean when you tell her to spread some peanut butter onto a slice of bread, without having to walk her through opening the jar, scooping out exactly 2 tablespoons of peanut butter, and sealing the jar when she's finished. This time, she calls on Evan Yu. Evan tells her, "We are going to make a sandwich. Set aside a collection of bread containing 2 pieces. Pick up one of those slices of bread. If it's the first slice, spread some peanut butter onto it. If it's the second slice, spread some jelly onto it. Join these 2 pieces of bread together in the form of a sandwich, with the condiments in the middle." Mrs. Lovelace warns Evan that if he doesn't specify the angle of the edges, she might push it together diagonally, so she gives him a chance to update his instructions before making the mess. To your surprise, in a fraction of the time, a beautiful sandwich was created without any trouble. This is declarative programming. You don't have to walk the machine through each step because someone else has provided a set of instructions that you can use so that you don't have to think like a robot. The idea behind declarative programming is that you tell the machine what the end product is and some general guidelines of how to get there, meeting a certain set of specifications. The framework under the hood will translate that to a lower level of code. That would be frameworks like React, vue.js, Angular, Svelte, and many more. These are declarative frameworks. Now, let's see the same application we built before, but with a declarative framework. For example, I'll use React just to knock Evan Yu down a peg as he smugly eats his PB&J sandwich. Now let's do the same thing with React. What we have here is a React function component. So let's get started. The first thing that we're going to do is we're going to import the useState hook from React so that we can have some stateful values. Next, we're going to tell React what we want the app to look like by defining our DOM elements. We need an input and we need a button. We're going to give the button a label of check, just like we did before. We're going to give it some logic. We're going to create a current value state, and then we're going to give it a function to update the number and a function to create the alert. We're going to use the useState hook, and we're going to create a value called current value, and we're going to create a setter called setCurrentValue. Now we're going to create the function to update the number. Since we're going to be triggering this with an onChange event, we have an event parameter that we can reference. What we're doing is we're taking the event target value and we're parsing it as an integer and saving that in a new variable called new number. We use the setCurrentEvent setter and we're assigning it the new number value. We're going to create that function that creates the alert. And just like we did before, the logic is going to be the same. We're going to make sure that the number exists and that it's valid. First, we create an if statement. We're going to give it the same logic where it checks to see if it's a number and that the value actually exists. If these are not true, then we're going to create an alert saying that there's no number. And if we have a valid number, we have an else block. Then we're going to check if it's even, again using current value mod2 equals 0. We're going to create the alert to display whether it's even or odd. We're going to use the ternary operator, and if it's even, we're going to display that the number is even. If it's odd, we're going to display that the number is odd. We need to connect these functions to our DOM elements. First, check if the input is changed. If it is changed, then we're going to update the value with that top function. We have an onChange event, which is calling update number. We're taking the event, we're pulling the value out of it, and we're setting the current value. Next, we had an onClick event to call the createAlert function. When we click the button, this createAlert function is going to be called. It's going to check if the number is there, and if it's valid, it's going to check if it's even or odd, and it's going to display the alert. Let's take a look at this now. If we click the check button with no value, we get an alert saying no number provided. If we add the number 2, it's going to say that it's even. If we add the number 3, it's going to say that it's odd. Let's take a look at these side by side. On the left side, we have our React app. On the right side, we have our HTML document with imperative JavaScript. The left side is declarative, the right side is imperative. So let me ask you, which one of these looks easier to understand and easier to write? I'm not sure how you feel about it, but I'm going to choose the declarative route on the left side 10 out of 10 times. So which of these paradigms is better? I'd argue that declarative code is more intuitive and easier to work with, although it's usually only an option when using a framework or a language designed to be declarative such as Lisp, Haskell, and Erlang. If you have a declarative framework, you'll work faster, you'll be more productive, and you'll get frustrated less often. After all, you wouldn't use a screwdriver instead of a drill when you're building a house, would you? This has been the difference between imperative and declarative code. Please leave a comment below if you want more videos like this, and don't forget to join our Discord group at ourpassion.dev if you're new to programming and you want a supportive community of like-minded developers to help you on your journey. Thanks for watching.